Dmitry is here, and we're going to start one new day, JCon. I hope you'll successfully break through some Zoom global issues. At least I see a few minor connection problems. Please tell others if website doesn't work for you. You can still try to enter Zoom meeting ID and passcode directly into the application, and it should work. I hope that helps. So today we're going to talk about chasing the Grail. What's the Grail? They call the Grail of effectiveness, at least for cloud deployments. We'll look how we could help them without much efforts from our side as developers. So who I am? My name is Dmitry Chuyko. I work at a company named Bellsoft, and Bellsoft releases Liberica JDK, free distribution of OpenJDK, TCK verified binary, and we actively contribute to OpenJDK. You see like TLTS releases. We participated in all intermediate releases, of course. So you know how OpenJDK works. So we should talk about deployment. I already told that story. We often nowadays use containers, or even if you don't use containers, we think about minimizing resources that we consume if we do like bare metal deployments or virtual machine deployments. So for containers, let's talk about two popular options. First, classical ones, JVM-based containers, where we have all that layers with Java runtime inside. There's some OS packages required for that, required for applications, maybe frameworks, framework layer. What's good here? We can redeploy the very small top of this pyramid without touching the rest. So if you use layered containers, it's so easy to update top layers because lower layers are cached, so it's effective. But for clean deployments, we still need to transfer everything, and that may be not so harmless. Well, we have native images. Native image containers are smaller, and we'll see how smaller they are. But lower layers are much thinner, slimmer, but the top of this pyramid is a monolith. If we would split like this single executable, this native image, into layers, imagine that, we could not apply very important optimizations during static compilation. First of all, inlining. We have to make real calls between functional parts of application if it's split physically into different like DLLs or so files, right? And we need to resolve how to make such a call with dynamic linking, and we cannot make next compiler optimizations, classical ones, if we don't know anything about relationship between caller and callee. They just interact through the interface of system calls. So we cannot split at least easily and without pain this big top in the case of native image, but the entire container will be smaller. We also have great options of making super slim baseline here. For native images, there is an option of static linking. Please refer to the talk by Alex Shalaf, for example. then we can link statically musl C library into native image and to have a scratch layer as a baseline, which is exciting. But what do we lose here? Well, we lose OS environment entirely, right? We won't have any diagnostic options, packages installation. So sometimes it's not convenient. And I would say often we prefer real shell, real package manager, so diagnostic abilities. Looking at some specific examples, you can easily go to, for example, Spring Initializer and create an application. The size of some typical CRUD application, if we compile it into fat jar, will be like 37 megabytes. It's microservice. But if you separate a thin jar and your application does literally nothing, only initializes itself, this jar with this minimum code will be less than 3 kilobytes. And if you update this almost empty business logic, it will basically cost you nothing. I mentioned polls that say, well, we still do manual Docker files, we still do bare metal deployments, we still do classical web application deployments, but container deployments are rising. And you already probably heard on this conference about Buildpacks, and developers do use that. And I will show how it works, at least in some basic things and what it gives us. I will return to the topic of base and parent images because we'll again look what can be effective there and what can be not so effective if we talk about reliability and options for diagnostics. If we take some base images with JDKs or some base images for suitable for our native image deployments, we should care about consistency, about fixed vulnerabilities, about compatibility with what we are going to run. If this if all OS stuff is compatible and ready for the JDK, how is it installed inside? How is it tested? And if it's not like a classical JDK, but a native image, we still need to care about compatibility and some possible issues. So again, we have simple option, right? I need OpenJDK, I get OpenJDK. But think about what's inside that container. Do you really know what is the JDK, how it's updated, what's the update release cycle? And I will give you a hint. It's different for different versions. The answers are different. Different vendors, different update cycles, different OS layers. Surprise. Inside this image, we have a lot of stuff. We wanted a simple thing, but we got something quite universal. But it's almost half a gigabyte on disk. And yeah, it's slightly below 300 megabytes over the wire. And if we deploy a lot of such containers on clean machines, we may face some problems, especially if the infrastructure was not warned about this movement. Smaller containers can help us here. And again, remember, we have two options nowadays. We have native images and we have classical JVMs. So we'll try to minimize both. Well, as I promised, we will do not so much effort to achieve that. Well, let's take something cloud ready, right? I will consider two options, cloud native Buildpacks and some image from the internet. All right, let's start from the very simple thing. Around 50% of deployments are still on JDK 8. That's both sad and exciting because so many options for support providers. But if you take some image of JDK 8 and look what's inside, hey, look, there may be not the latest JDK version. And it may be so not latest that it is like more than a year outdated in terms of security updates. That's not good. And the differences in size may be also quite big, even if you have the same base operating system layer. Maybe not so same, but like two images both based on CentOS. Okay, but at least this update should contain flight recorder, right? We all like flight recorder and mission control for diagnostics to find out what are hotspots in our applications, what happens during its lifetime, because we can just turn on that monitoring and profiling, slight flavor of profiling in production. It just doesn't work. Why? I don't know. So it's the functionality is in OpenJDK, just take right distribution and it will work. As an opposite, let's look at cloud native Buildpacks. And if you create a project and say, okay, we're not going to assemble a native image right now, right? Find that property in your, for example, POM.xml file if you use Maven. And you'll see that simple Maven build command assembles you a ready-made container image, which is already layered. It has Liberica JDK, by the way, inside, Liberica JRE in this case. We assemble Spring application, Spring Boot, and it's really small. The entire image that contains all the application files is below 300 megabytes on disk. Okay. I already gave a talk about JDK now ported to Alpine Linux, and I will just show you that again, that Alpine Linux is extremely small, and it still has good options for diagnostics, for working with arbitrary things inside your container. For example, it contains shell, package manager, and a small effective C library, now suitable for special build of OpenJDK. And other distributions are like 10, 20 times larger. You see that there's a big difference. And distroless images are not very different in size. And if you add C library to like distroless image, it won't have package manager, but it is larger than Alpine Linux. Yeah. It's great. The port has been delivered to JDK 16, and now you have multiple distributions assembled from the same source, but ports to JDK 11 and earlier, like here's the picture for 15, for 17, I already shown the picture. The disk size is below 100 megabytes for this image, and also JDK 11, JDK 8. And if you pull such an image based on Alpine and musl, and specially optimized and prepared JDK to have slim size, but still be fully compatible in terms of Java specification, that's a very important and key point. This distribution goes through all testing cycle. And this poll is only 4 seconds, and it's super slim. But hey, let's go to the internet and find something smaller. Like for JDK 8, you see there's an option to have Alpine musl build. It's a custom port, but still, again, it goes for all the testing. And we find something smaller. Well, not a surprise, because we can compress standard Java libraries packed as jars in JDK 8. Prior to JDK 9, it was so. Well, what's the problem here? How do you think? Yeah, and by the way, if you have any questions, please feel free to interrupt me and ask them, or write them in chat, and I'll answer them after the talk. So again, here we have compressed jars. Why don't everyone compress jars? Because then you transfer your image over the network, over the wire. You compress it again. And what happens if you compress already compressed archives? The resulting archive become much larger. So that's a problem. That's not free, and it's not good. So you will save disk space, which is probably cheaper than your spendings on network. And what's worse, if you compress not in the right way, you actually can compress in the right way. But if you do it wrong, you have slow decompression. And here, the application that we all know for well, Spring Pipelining, and we started, and we see that it loses like 13% in startup time. All right, but let's try to profile an application. I recommend Async Profiler, a great tool that gives you many details of how your code works at low level, and how it interacts with system, and what happens inside JVM itself, and all in the same picture. It works on different systems. So here we just prepare our container for using the profiler, right? We have package manager, so we can not to have for this preliminary steps performed for each of containers deployed, right? We can save that, save something here. But if we need to perform diagnostics, we go log into that container, add some additional libraries, and then try to profile finally our Java process. Well, something is wrong here. We just see that, hey, all time is spent somewhere inside JVM. Let's take another image. So in this case, Liberica. And we'll see detailed information about what happens inside virtual machine. So we see that C2 compiler works here, and we see different phases. How do they affect the CPU consumption? Why does it happen? Because one image has symbols necessary for profiling and another does not. It's not a big problem. It's not a debug build. We can just include the useful symbols into the build. It's a basic thing if you care about it, but you should care about it. Well, as I mentioned, slim Alpine image containers are available for all LTS versions and not for just x86 platform, but also for ARM64 CPUs. But what about Alpine itself? It is a Linux distro, so we can install OpenJDK there. Yes, we can. Let's do the same. Install OpenJDK 8 in this case, and try to, well, apply a basic diagnostics command, J command. But this command is not found. What's the problem? Well, it's actually there. We can invoke it, and we can finally ask our virtual machine, what's your uptime? And instead, we'll see a thread dump. That's really sad, because if you prepared your Java distribution right, if you prepared your operating environment right, especially for working with Java stuff, right? It all works. You just call JCMD and you get an answer. All right. What about public registers? Public registers are good because they're public, and sometimes and up to some point they are free, but after that point they are not. You face limits, and in this case it's good to have a trusted registry, which also helps you to check to validate what artifacts you are getting from the outside. That's what vendors can give you if you work with some JDK vendors, and you can combine this registry with some your internal mirror. You can mix inner and outer layers for your final container images. And we also put early access binaries into such registries. And we also put builds with custom fixes. So some commercial customers of JDKs need urgent fixes before the fix goes through the public OpenJDK repository. So it's a convenient way of providing such things. It basically works just like Docker Hub, but with username and password. And then, for example, our work related to decreasing the size of container for JDK 11 that has been previewed there, and other nice optimizations like decreased memory footprint. And for that especially, we can look at the very good picture. How can we get something for free, right? It is that a clinic application. And we just started to put now load. And at the start, from the beginning, it consumes some memory, right? And then it finally starts and the memory stays the same, consumed memory. But look, if we just take the recent update of JDK 11, we save a lot of footprint. That's amazing. I will remind you about choosing your option for deployment. Again, first, it's good to decide are native images good or bad, right? Do we need diagnostics, all familiar tools? Do we have often redeployments on clean hosts, or we have small updates? So in this case, probably thin layers are better. Do we have often restarts? Because with native image, you get almost instant start for your service or your application. And if you have quick restarts, well, something Lambda-like, or you have, I don't know, often failures, well, that's an option. If not, think of how familiar your environment should be. Do you need traditional, for example, YAML and apt package managers, or APK is also fine for you because it's basically the same, allows you to install packages, or do you even need a package manager, or do you even need a shell? If not, well, maybe distroless or Scratch, again, native image. So if you don't need something specific, and even glibc, it's not obvious to do you need glibc or not, probably then you don't need the glibc. It's fine to work on musl. You can end up the very slim image based on Alpine musl, and then thinner features. Let's talk a bit more about native images. Native images are produced during static compilation, static or ahead of time compilation. And there used to be a feature, ahead of time compiler in JDK itself. But the design of this feature, when code has been generated as a dynamic library, and it linked against some dynamic things with the rest of the code, and possibly you could use everything Java lets you to do, like override any class, etc. So many checks were in that code that really made it ineffective. Another problem was that, yeah, the solution itself was entirely based on Grail compiler, used as a static compiler for this purpose. But the Grail compiler code has been downported from GraalVM project to OpenJDK project. And that took a lot of manpower, a lot of efforts from Java team in Oracle. So at some point, it was decided to stop that process, because there is a good option of generating native images instead. But JVMCI interface for Java-based dynamic compilers, that also helps both GraalVM and GraalVM native image. It's still in OpenJDK, and it's not going to be removed or something. So it's a very important part of the API. As you know, and again, I'll send you to Alex's talk. There are CE and EE options, flavors of GraalVM. I've talked about Oracle builds, and there are quite clear licensing policies. So we is licensed like Java SE, and community build is JPLv2 with class path exception, right? But we look how often native images are used for containers, and that is raising an important way of deployment. So as a vendor, we decided to help developers and to provide our own vision of native image tooling to help exactly that, not focusing on dynamic aspects of GraalVM just for static compilation. What does it mean? As a vendor, we support the largest number of platforms, I mean, OS and CPU architecture combinations. So we decided to produce builds for more platforms than default builds of GraalVM. And Liberica native image kit is built around LTS versions of Liberica JDK. And it still has all the original components that allow you to use multiple languages, for example, and to mix them. And it's, of course, based not only just Liberica JDK as a core, but GraalVM, the appropriate version. And as I said, more platforms mean, in particular, Alpine Linux, with musl C library as a main C library. So we added extended support for Alpine and musl for both a process of compilation, so for tooling, and for runtime of your already compiled native image. It's very easy to try Liberica native image kit. You can just go and download it or just Google. We'll look at some smaller, even smaller servers than the one that I showed you before. You see, if it really does something, then it's like not 3 kilobytes, but 30 kilobytes. And fetchjar can be like not 35, but 17, but still the order of magnitude is about the same, right? So if you go and study what Spring Initializer generates for you, you can reproduce it even in your existing projects. So of course you will have some configuration for Spring Boot Maven plugin, right? You may need to tune it. You will have to add some specifically designed plugin called Spring AOT Maven plugin. That's not about AOT compilation into machine codes, but it's about producing some Java code or bytecode in advance during the compilation during Java compilation of your application to help native image to avoid dealing with dynamic nature of Java, like reflection, dynamic proxies, etc. So it's a different implementation of core concepts in the framework that help this way of assembly. And then you will have Spring Native plugin itself that manages both GraalVM work and other stuff. So it's the core support in the framework. You probably saw talks about Quarkos and maybe Micronaut, like here, for example, yesterday. There was a good talk about Micronaut. You may notice that all that frameworks, they manage native image compilation inside plugins because it's a complex task. For simple applications, you can just invoke native image to compile a jar. And surprisingly, if you take, for example, Spring Boot jar and invoke that, it will work. It can give you something working, but fallback image, so-called fallback image, will work instead of real native image functionality. Because the compiler will meet a lot of dynamic things that it can handle. And in runtime, you just fall back to regular JVM and you have all the same performance, same code generation, etc. Well, to avoid that, you need to provide a configuration. You need to specify all your reflection, all your some customization things. You can write it by yourself. You can write it by hand. You can collect it using a special agent that records everything you meet during the work of your application, like all reflection calls, etc. But it's so complex. The framework knows what it really needs inside, right? So it just can help with it. But you need a special plugin for that. And you can have a custom configuration for GraalVM native image plugin. Why do we need a custom configuration? Well, we'll look a few slides ahead. So we need that for a flexible build. For example, you know that native image technology, it's not that young, it's mature, but still not so stable with complex frameworks like Spring Boot on this example. So something may work in one version and not work in another version. You can just update sometimes following the defaults that framework build plugin provides you. So if you just rely on defaults build and everything works, you're fine. But sometimes you're not. Then you can just go download some build, like for example, Liberica native image core, a special assembly of Liberica native image kit designed out of the box to produce native images. So it doesn't have other tooling, but instead, out of the box, it has a native image tool. So you can just download, unpack it, and use it for native image assemblies. And here they invoke that profile, and inside that profile, we specified GraalVM native image plugin. So it will take the assembly from Java Home and it will use it to build the resulting native image. And all the process will be still managed by Spring Native plugin. That's a flexible way. In the simplest case, you just specify a native image true, or if you use Spring Initializer, it will be, and you specify it that you use Spring Native as an experimental feature, it will be true by default. And you invoke the very same command to build the resulting container image. If all the process of involving cloud native Buildpacks, you just say Spring Boot build image, and you get the resulting container image, div native image executable in it. You see, there are some options here, like for example, you can use different builder, but anyway, what's inside? Well, let's even take one more step. Let's perform that build in the Alpine Linux environment. So here we invoke the same native image profile, again, the flexible one, but we invoke it inside a container. And that container is Alpine Linux. It's just a regular Alpine Linux container. It can be enhanced via a Docker file or enhanced in place, like here. We have dependencies required to run the native image kit tooling. So we take either NIC core, or we take regular NIC for Alpine and install native image. And then we finally invoke Maven in that container. So it all works in Alpine Linux environment, and they get binary suitable for Alpine Linux. So we can put that Alpine musl compatible binary into Alpine container. And if you remember, it's 5.6 megabytes only on disk. We'll need some dependencies, runtime dependencies, to run the resulting native image. It will add 7 more megabytes. And the resulting binary, as you remember, is 57 megabytes. So it's like 70 megabytes. That's your container. And that's really good. It's visibly smaller than traditional would expect, like not 10 times, right? The difference is like 1.5 to 2x, or it's just a delta, right? Because as you may notice, the size of the binary produced by the native image is larger than the original jar file. So native code, and that's not a mistake, that it should be like this. Bytecode is compact. And here we save by having all the virtual machine linked into the same binary, and it's substrate VM, which is quite compact. So it's different. And finally, this application in this container, it starts as a tiny fraction of a second, 1/20 of a second, which is super fast. But that's not the only, not all the same savings, because let's look at the same picture. So again, we saw how updating your JDK and optimizations in JDK can save your memory for free, right? So here GC just doesn't take more memory than it really needs for regular JVM. But if we migrate to native image, we save even more. So if we have very dense deployment and we care about physical memory occupied and we don't have much load on services, right? Because that may change the picture. Everything is super sweet. You can go and try again, as I said. Go for Liberica Native Image Kit and the Liberica Native Image Kit core. And thank you. I would be glad to answer some questions. Please feel free to join voice or write your questions in the chat. Yeah, thank you. Maybe you haven't noticed that. I should mention that especially that if you take Spring Boot and if you say, okay, I will use Spring Native, and you build your containers. Under the hood, Liberica Native Image Core is used. So you already got that tooling if you use that default plugins. Okay, please also check the chat. There's a message about how you can go and get some GraalVM online training. Don't miss it. And maybe to answer your questions or to make you have more questions, there's a promo code. Check it, please. Okay, if there are no questions, I think we can end up the session. Thank you once again. Yeah, find me on Twitter or wherever. I'll answer your extra questions there.